You use joints for different reasons when you make your assembly. Let's take a closer look. You can create joints between components in your assembly, and your joints define the relative position and motion between two components. Joints give you the opportunity to simulate and understand motion in a digital environment. Just like with other commands, you can interact with joints either in the browser, in the canvas, or in the timeline. Your selection order matters. Your first component selection moves or rotates along an axis in the direction of the degrees of freedom arrow relative to the second component, component 2. In other words, select whatever you want to move first, then decide how you want to move it and what the limitations are. The rigid joint type will lock your components together. This joint removes all degrees of freedom. Therefore, the options look a little different compared to joints with motion. A common scenario is a welded or bolted component. You want the components to stick together. The rigid joint has a vibrating simulation that, unlike other simulations, doesn't simulate the movement since the joint is rigid. The revolute joint lets your component rotate around your joint origin. Use one of the three options under origin mode for your first and second component and find your snap points. First selected moves first. Joint motion limits are accessible for several joint types, and we will demonstrate them on another joint type. Just as with probably most computer software, a contextual menu appears when you right-click on objects. Here, a small menu appears when you right-click the joint, and you can allow the joint animation to run when you look at your assembly from different angles. The slider joint moves your component without rotation along your selected axis. This component is 200 mm long, and you will soon see why I show you this measurement. Select slider as your motion type and select the component that you want to move first. This is what the movement looks like without motion limits. Let's set a maximum of 200 mm and make sure to activate it with the checkbox. Your movement is now adjusted. Play around with your settings to get a feeling for this tool. Rest is simply where your joint rests. The joint counts the motion limit distance from the joint placement, which in this example is placed at the end of the green bar. The cylindrical joint rotates and moves around an axis. Sometimes it's easier to find the desired joint snap placement if you turn off the visibility of other objects. You can set motion limits for both your rotation and your slide, and you can preview one motion at a time or all motion limits simultaneously. The limit is counted from your snap placement, and even if it says 0 mm as minimum, it won't affect the moment until we activate the motion limit. And that's it for a basic introduction of the cylindrical joint. The pin slot joint rotates and slides your component on two different axes. Finding your snap point can be tricky. You can make it easier if you lock onto a plane. Hover over the face, press and hold Control on your PC and find your spot. As you see, this joint slides along one axis and rotates around another axis. You recognize the possibility to preview motion for one or both motion limits. The inner distance is 100 millimeters here. Switch to the Slide Joint Motion Limits menu. This joint is placed in the middle of the pin slot. Therefore, we set negative and positive 50 millimeters as our distance. If the joint was placed at the end, well, then our minimum would be 0 millimeters and our maximum 100 millimeters. Good job following along. Let's proceed with our next joint. The planar joint slides your component along two axes parallel to the plane and rotates your component around a single axis. You can set up all kinds of movements with all those sliding motion options. Finally, we have the ball component. This component rotates around all three axes. You are recognizing the similarities from other joint types, but also the differences for the motion settings. Small flags indicate the different degrees. It's easier to see them when you preview degrees outside of the joint settings environment. And that's it for joints. Now that you have a basic understanding of them, you just need to practice them in different situations. Let's summarize this information-intense lesson. You can use the X, Y, or Z axis for your joints, but also a custom axis, which we demonstrated earlier how you can set up. You can edit your joints by right-clicking on them in the browser, in the canvas, or in the timeline. You can animate your joints and see them in action. Some people find joints challenging, and that's perfectly fine. We're off to a good start with a broad picture, and we will leave the joints here for this lesson. Thank you.